Hello everybody, what's up? So this is a relay. It's running on two batteries, two SSG circuits. This multimeter goes to this battery, and currently this battery is charging. Because let me tell you how this works. The SSG drive goes to the battery that it's aligned with. So this circuit is this drive and this coil. And this output goes to this battery over here. And then this battery's output goes to this one over here. So currently, this is the SSG circuit, and this is SSG with gen mode. They're both working simultaneously on the wheel, but they're at 90 degrees, so they work simultaneously with the battery charging as well. It's just that the SSG over here isn't generating enough. It's not generating enough. So we're slowly losing on this side. But luckily, I have this gen mode circuit over here still, and I can swap them out. And I think they run a little bit better. I still think that one side would be losing, but I'm not sure. I don't know. One side is a little bigger than the other. This side is 730. This side is 830. So it's 100 turns more length in the gen mode coil, which is good. The long coil should be on the gen mode. But I think I'm going to swap it. And somebody might be asking, what's that third coil back there? Why is the power supply on? What's the light doing? Let's see if you can even see the light. Yeah, kinda, in the corner there. Well, it's a booster. It's like an underlying coil that is totally separate from the system that's being applied. And what it does is it makes the wheel spin a little bit faster. But I'll turn it off just to see if I'm wrong. I will turn it off. It's a lot quieter, that's for sure. Awesome. So, oh, I think it's slowing down though. Let me back that coil out. Since it's not being used, let me back it out. You heard it chirping, didn't you? Like, as soon as I backed it out, it stopped chirping. And it's not on, there's no electricity going through there. It was just chirping. I think because of the one trigger coil, there was an interaction between two strands. No, let me play with this pot right here. I think we're gonna get a little bit of speed, but I don't think it's gonna gen any faster. It might. Let's just play with it a little longer here, see if we can't get this one to go up. Alright, it's starting to go down. So that's how 1205 now went down one, if that's okay. I'm just, there is a opportunity to view the differential for the most part, because they are 100 turns in differential in length, the two coils, but they're the same gauge. And the circuits are SSG and SSG with gen mode. And currently this battery is charging even though it's being used, and this one is not. This one is just draining slowly. So the resistance is playing a huge part in all that. The potentiometer is definitely playing a huge part in all that, whether it's going up or down, or but I think ultimately this one is going up. I mean, it's gone up like 4/100 since I started running it. So like the gen mode makes it go up running SSG. Now if it was running SSG gen mode, I don't know. I think it'd be a little bit more expensive. So it might not work out any better, but you know, it'll gen more. You'll get your spike. And then I made this switch here, or this diode. It's for, you know, the back EMF. You got one going one way and then it going the other way.
Alright, I got a poll.
Awesome.
People that don't wound their own coils at home.
Yeah.
62% now, 13 votes. But I got a comment saying the only coils I've wound myself were vapor coils.
Nice. For like an e-cig or what? Are like the same principle as a e-cigarette. So I think that's cool, man. I think it might be moving even faster than it was with the third coil up there. And that's really weird. Although it is...
Oh, my motor coils is my occupation.
Nice. Man, tell me more. Am I on the right track with 20 gauge, or do I need to go a little smaller, like 24? Because I heard people have been, using 24, and I'm willing to go there. But I got a lot of things in 20. That's just why I'm asking.
Max asked for your opinion on model trains.
I think model trains are awesome. I think it's a really would have been, if I didn't have such a bad tremor, it would have been something I would have gotten into actually. Transport Fever is one of my favorite games. So, and you know that whole series, I love that series. Transport Fever, if you didn't know, is a game that allows you to connect cities through transportation methods, and trains is one of them. So I think that's cool. You can deliver goods and services, people, mail, all the above. And the more cities you connect to the line, the bigger you get, and so on and so forth. It's a great way to expand your imagination, like let it explode a little bit. So you know, just imagine where all those, you know, train stations would go. But I'm thinking it would cost a lot of money to, but it might be something worth investing in.
He said used for rebuilding three-phase motors, or used, and for new windings.
Okay.
So that's probably the main. You got, yeah, they probably have a machine.
So this is awesome, man, because this battery is actually charging, even though it's being drawn from. That's awesome. So let me explain the connection here. This output, this SSG Gen node output is connected directly to this battery. Now I couldn't directly connect the other one. And that might be what the problem is. Because every time I try to do that, there's a huge, like, draw on the battery, and it's like it's short circuiting. But it's only because, and I understand why it's happening. Actually, I don't. Oh, it's because they're flip-flop. The power, I just don't understand why it does it though. It should be good because there's diode in the circuit. On the output, there's a diode there, so there should be no problem. But what happens is it backs up and it starts to oscillate between the outputs. So the outputs become connected. I just don't know how it's doing it. Oh man. Because when it really demonstrates itself is that both outputs are connected, right? And then the input is connected on one side, and then I connect the last input on the other side, and it starts sparking. Starts drawing heavy on both batteries. I'm like, okay, that definitely means there's a short there. But so what I did to fix that problem is put the cap bank in on one side. See, so I don't think there's enough energy flowing through from the SSG alone to start pumping into the battery. There's more pushing back this way. Like up to this point, I don't even know if you can see that. Cap bank right there. Up to this point, the energy is flowing this direction. So, and there's got to be a certain amount of force or a certain amount of current going that way, a certain amount of flow going that way for it to go that way. I don't know if there's enough. I mean, it's been a while. It's still 12:05.
strands of certain gauges, certain number of turns, certain size and length. Largest coil I've done is 5 strands.
Oh, I've done 10. Crazy, man. And it made it small. I made it a teeny, like 15 turn, 10 strands of 26, I believe it was. It was a crazy little coil, man. And literally at like a volt or less, it was drawing 5 amps.
Alright, boss said put diodes on the output and input of the charging battery and the running battery.
It's a relay, boss. This is a 180, 90 degree relay. There's no charge battery or input battery really. They swap.
Then Break said
Oops.
16 gauge, about 24 turns, 10 inch between centers.
Oh wow. Wow, man, that's wicked. Heck yeah.
And then Jay's like, what's going on, bro?
What's up? This little meanie right here, I think it's a 14 gauge and 18 gauge, 14 and 1 millimeter. And I believe it's got to be around 20 turns, maybe. But I mean, you hook this up directly to anything, and it's gonna fry. It's gonna blow up. Because there's gonna be just way too much current flowing through it. So that's a 14 and 18 gauge bifilar. I don't even know why I did it like that, because the only thing you can do with this is hook it in series or run it parallel through a multi-coil system. So if I made like a bunch of these, I could hook them up in series. But running each one of those strands by themselves the way it is, man, no way. And this is a Litz wire coil underneath that, man. This coil is pretty mean when it comes to generating electricity.
That was for the shop head to insert in a motor that burns out. Had to wind 18 of those coils for that motor.
Dang. Hell no. Well, I mean, I don't know. Was it worth it? I mean, that's a lot of work. Yeah? Had to be worth it. Bad question. Here's a 16 gauge coil. It's 260 turns of 16 gauge. So that's a nice one. I like the wider coils. They leave you more room for error. Kinda. The wider bobbin, I believe, is more forgiving, especially if you're using a trigger coil. So, let me think here. This is 20 and 22 in series on this one, and this is no, this one isn't in series though. This is just, and this one might not be in series then either. Let me look again. Okay, no, this is 730 turns of 20. This is 830 turns of 20. Now this coil has got two, that's doubled up in this coil. It's got virtually 1600 turns a 20 gauge in there. And then there's two trigger strands. So I can run both of these SSG and an SSG gen mode into one coil if I wanted to. But I wanted to run it in a relay. So what I did was I got my 180-degree magnets and I got the 90-degree placement of the coils. And it's been running pretty good so far. Actually, one side's charging. The side that is being, that the output the battery that the output is charging directly, and is the output of the SSG with gen mode is what's doing that. And it started at 1194, it's now at 1195 steady. So that is definitely going up. And then this one's slowly going down, 1204.
Yeah, it took him 2 days to insert all the strands into it. I think it was around 18 kilowatts.
Holy
Largest
cow.
coil I've done for my own hobbies was about 150 feet, 5 strand, 22 gauge.
Nice. 5 strands, 22 gauge. That's cool, man. And then the other one is for work, I guess, yeah?
Yeah, he said occupation.
I got you. I don't know, man. What do you think about the coils I got on the table here? Because, you know, I'm not gonna like just keep making coils if I'm doing it wrong, you know what I mean? I need to know more than I do, I think. I mean, this is a very efficient, but it's not going very fast, you know, let's see how fast it is going though, before I start running my mouth about it.
Alright, on the pole, we got 24 volts, 50-50.
Oh, wow, nice, neck and neck on the pole, that's cool. Alright, so 750, 765, 765 RPMs.
Wow.
That is not very fast. Not what I would consider to be fast.
Right. I'm just like fascinated.
That's definitely a steady pace, though. I wonder, now that I got my tach meter in my hand, if I turn this on,
Those are pretty sweet coils for a hobby. Are you running the sense coil in single resonance or multiple pulses per magnet?
just single right now. I do have a signal generator over to the side here where I can do multiple pulses per, if I wanted to, and I do experiment with that a lot. No way. That's definitely slowing it down. And I think it's expensive to run the gen mode, more expensive than it is to run SSG on its own. So there's a trade-off there, and I just want to make sure I'm making the right choice. I think they should be equal though. I just think it's gonna drain faster for some reason. Alright, so this one says 1205 now, but I've tightened up the resistance very far. It's like 8 turns in. So that's a 1K pot. I'm thinking it's about 800 ohms right now. And I have to hook up a pot for the other circuit. Right now the resistance that is on the circuit is 460 ohms. But I think it's really interesting how I turn on this potentiometer for this circuit and this multimeter over here responds. I think that's pretty cool considering they are now not connected really except for the output and the input. Oh, they are very connected, I guess.
It's still cool.
That's yeah, it's still cool. Heck yeah.
Is that a 3D printer? Neo magnet rotor in the background.
3D printed neomagnet rotor.
Gray, dark gray.
Yeah. Yes. That is a 6-inch 4 neodymium magnet cubes. I can fit in it, and I'm running 2 in there right now at 180 degrees. So let's get this out. Okay, so this is on the bottom there is a Litz wire coil that's 100 strands of 38 gauge. So it's about an 18 gauge wire. So it's Litz wire 18 gauge 100/38. Alright. And I use it to generate. There's not enough there when you look at it from a perspective that it's an 18 gauge wire. There's not enough there for it to be a pickup coil. You need more wire. You need more length in it is what I'm saying. You need more length. So we're using it as a generator, and then this one is 12,960 turns of 32 gauge. 3 units in parallel, so there's 3 units that are 4,000, 230 or something like that. I don't know, somewhere in there. I can't reverse the math right now, but that's how I got the 12,960. Awesome. So with 15 volts going through this bottom coil, we can get I think it's 15 volts. No, it's 5 volts. Jesus, 15 volts. I don't even want to know. 5 volts in, and we're going to do this. We get about 345 AC volts out through this coil. That's awesome. When the first time I saw that, I was like, good God, man, it's a lot. All right. So I just had a sudden urge to see maybe if I had like a better coil. I mean, I did have better coils, but they broke like down at the seam. So I wish there was a way for me to like elongate the beginning end of the coil, make it longer, but I haven't found a way to do that. Sometimes it's just you tighten the knot, you tighten the nut too tight, and you snap it right at the beginning, and you don't even know it. So, you know, I've had a few do me that way, and you know, I try my hardest just to just be aware all the time when I'm doing it of what's going on. It's definitely worth putting in the extra effort. Okay. Just turn it down to 3, turn it on.
That's pretty neat. Do you run it with an iron or air core?
It's an air core right now, but it is set up to fit 2 soft iron cores in there if I choose to. So it's pretty modular at the moment. But it's a tiny core, you see what I mean? It's not going to make a huge difference, but I mean it'll help a little bit.
You said that 5-strand one I wound cracked in half from a capacitor discharge.
Holy cow, man, that is a hell of a discharge with force. It's amazing. I don't know, man. Did that one scare you? There. Ah, yes. Anybody have any particular wave they want to see? Oh, hold on. I gotta take one of these meters off and put it, attach it to this coil. I think it's gonna be this one because this is the most stable side. It's not dropping. We'll get an oscilloscope reading off this one too. That'll be pretty neat. Usually I got them hooked up to the battery, so there's no point to really do an oscilloscope reading. But here we go. going to move this up here, hopefully without. Alright, let me start putting in a little bit of frequency. Okay, my bad. There we go.
Ravender's in the house.
Hey, what's up, man? How's it going? Ravender. Nice. Okay, we're at 7 hertz. 7 hertz. Forty hertz.
3500 UF at around 200 volts. Yeah, once I got over the shock of all, got sad that I was in the coil.
Awesome, man. That's
About a pound and a half.
awesome. This one's 2 pounds. With 2 strands of 20 gauge and 2 strands of 32 gauge at 830 turns. But what I used to wrap it was a, one of those programmable electronic rollers. Oh, there we go. 200 hertz, and we're up to but see, I can see the wave kind of we increase the frequency. It'll go up and down. The voltage will go up and down.
Tried the RPM of your motor 2 times. Or times 2. Then divide by 20. Or, jeez, I'm blind right now. Try the RPM of your motor times 2, then divide by 60.
For the length of the coil,
Is that a 3-phase motor?
no, it's a monopole. Right now I'm using SSG to drive it. DC brushless motor.
10 mics.
Awesome. 400. It's 400 hertz right here. And right now we are generating 181.1 AC volts off of 3 DC volts and 735 milliamps. So this little coil down here that I was talking about, the Litz coil, draws a lot of amperage. And that's one of the reasons why it's not a good generator.
What do we go with this, the speed per volt?
Speed per volt? Well, let me get the speed real quick. You want RPMs per volt, right? Of input or generated volts? Because this meter right here is this solid state generator over here. The wheel is going 730 RPMs. And then divide that by 60.
Yep, and that might allow control of speed through the generator.
Okay. I got potentiometer. I want to go in a little bit faster, so I'm going to loosen it up just a little bit. Let's see if I got that right. No. Huh. Went the wrong way with that. I need to tighten it up.
Some BLDC motors are marked 13 kilovolt, 2000 kilovolt, and SK. That
Okay.
means 13,000 RPM per volt.
That's amazing.
Oh, and he said, am I right? Question.
I don't know. Huh. I don't have any idea. That'd be cool though, to know that. There we go. We found it. The spot.
Oh, you didn't realize you were running two systems concurrently right now.
Yeah, I was thinking about maybe even combining them together and having this third SSG with gen mode run the current for our solid state, which is now generating 180 volts off of 3, which I think is really cool. It's got a ferrite core, really small one, like 3/8, 2 inches long. Really neat. Alright, let's see if we can get that any higher. Wow, 205. Nice. 211. Wow. Wow. Dude, that is cool. That's like unreal. 240.
Did you use neomagnets?
Yes. Yes, neomagnets. The core is ferrite though. For this one. These are air core. Let me show you what I got for them though.
Thousand views.
Nice. Got that. that soft iron. And should I put the cores in? You think I should put the cores in? That'll help, you think? I can do that. I'm gonna have to back it off the wheel a little bit though, because I'm only using duct tape to put the cores in. So 423 hertz. Awesome. That's awesome.
Dyson motors have neo magnets inside of the rotor, same winding as you did.
Wow. That's pretty cool. Actually, I'm curious as to how these cores will affect the generation side, at least, of the SSG side, at least. So I'm gonna set that up. Alright, so I need my duct tape. Woo, I see it. I see it.
Yeah, and those Dyson magnets have a diameter of about 1 centimeter, but can provide up to 500 watts.
That's awesome. That's freaking cool. Oh man. Now this coil got hot, so it might be, let's clear that junk off there. Might be too small now.
They say with neomagnets and air cores are like higher voltage. Soft iron might give you a bit more RPM at battery voltage with increased current.
That'll increase the current draw.
Yeah, and that's the
That's exactly the opposite of what I want. Yeah, I'm not
The
trying to
soft
do
iron.
that. Okay, so we'll forget about the cores for now.
Place the magnets in the rotor, not the stator. Yep.
There we go. Yeah, it's a tight fit now. And it got shorted out a while ago, and I think that's why.
That's got me interested in the gen side as well.
Sorry, what?
I think it doesn't help in stator because you need alternative field. Yeah, some of it might be out of context, so we'll just keep
Okay.
going.
All right.
The one he's putting in isn't polarized?
Is the coil polarized? It's wound in attraction mode. So you know you go to one side and then you go back real fast. And then you go slowly and you go back real fast. So I don't know, I guess it is kind of polarized. Nice.
If you put the ferrite core inside of the spool, it will help a lot, but it will take more amps.
Oh yeah, this is hooked up to the other thing now. Let's take a look at the oscilloscope reading. Gotta turn the power on though. Wow, dude. Wow. 720 peak to peak. Wow. That is amazing.
I think you thought you were putting magnetic rods in the coils.
I do have 3 that I can use, so is that a good idea? Oh, I see. If it's a polarized coil, it'll work. Instead of like a bipolar wrap. And yeah, that one is wrapped. I'm not sure which way's north or south, but I could probably figure it out with the measurement thing. But then I have these that can go in there. I think. I mean, I hope it's bad enough. The hole. Yeah, this is a beautiful sine wave being generated by the Litz coil at 420 hertz, 423 hertz.
What data are you collecting? What experiment are you running?
Let's see here. This experiment is a relay. It's running an SSG against an SSG with gen mode. This experiment is a solid state generator. We're running 423 hertz and 3 volts, 700 milliamps through this Litz coil on the bottom here. And then this coil, this 32 gauge coil, picks up a lot of stuff. Yeah. Yeah. So it makes a really nice sine wave, I've noticed. It does have a ferrite core in it. It's about 13,000 turns. But I think the sine wave that you put in is kind of going to be the sine wave that you put out. That you get out of it. It's like I'm using a signal generator to generate the wavelength. So I'm going to get a nice wavelength coming out of it. Alright, I'm going to try changing the wave. See if the wave changes on this side too. I'm pretty sure it's going to do something different.
Alright, we got 40 votes now, 55% yes.
Beautiful. Alright, can you see it? There's our sine wave. And that is 720 volts peak to peak. Beautiful AC. It's not three phase though.
Right, he said it may choke field generation, unsure if it just bias it. I wasn't paying attention to what that was in reference to.
Okay, so this is going to be the square wave. Square wave right there. So we put a square wave in and we get a massive surge to our sine wave coming out. 423 hertz. Let me try and get a reading on that. I can't really see it. 900, looks like 900, 800, 900 volt peak to peak. Like 880 or something. That's great. That's square wave. So it doesn't change to a square wave coming out, but the sine wave that comes out is amplified. Pulse. Triangle. So this is the sawtooth, the triangle one. Partial sine wave. Almost. OMOS. I have no idea what that is. But it looks pretty strong over there, man. Looking pretty strong. DC. Flat line. Half wave, half wave. Wow, okay. Full wave. Ladder. This is ladder. Reverse ladder. Noise. Nothing.
Did you have any polymer bipolar capacitors rated a bit higher than your output? It'll shape it a bit, if not rectify it into electrolytic cap for some fun discharges.
EXP Rise. Decay. Now we're back to, oh no, Sine. Alright, so that's pretty much it of practical wavelengths. There we go. Sine wave. That's the one I like. Even though square wave has got a little bit more punch to it, I like the sine wave input better.
Wonder what those terminals on that coil feel like. Whether you get a decent shot from it.
Yeah. I don't. Yeah, I've shocked myself. You do get a decent shock from this. It's not anything you can't pull away from though, so it's not a big deal. Excuse me. So, my question is, if I replace this SSG with this SSG gen mode over here, and they're both gen mode, do you think that they would be able to overcome what's being spent, or do you think that the amp draw would increase too much if I switch it out? You know, I'm feeling like charging a battery or a cap bank. Yeah. I gotta find some chords, man. I don't know if I'm gonna be able to do that. Here's one. Uno. Man. I think I'm gonna probably take it easy.
We gotta check the battery.
Oh yeah. Oh yeah. All right. I gotta let you guys go. Thank you. Bye now. Really appreciate you. So cool, guys. This is awesome. Thanks for dropping by.